Okay, let's take a quick look at the layout of the system. First, we have the control card, the system controller. If you recall, this is the part of the circuit that generates all of the flash patterns and determines how long the system will be activated and control functions such as that. We have the charge controller unit, and the charge control unit, once again, that controls the flow of energy from different parts of the system, from the solar panel or from the battery itself. We have the circuit breakers, and these are the quick disconnects. They serve to protect the system from overcurrent, and the first one here goes to the battery. The second one here goes to the solar panel. And then we have the surge protector device, which is here, and the surge protector device is across the terminals, the output terminals of the solar panel circuit breaker, and in case of a high voltage transient, that will short and prevent the surge from reaching the charge controller and other portions of the system. And that's pretty much it. We do have some terminal blocks here. The terminal blocks, these first sets, are for the outputs, and the TS1100 has actually two outputs, an output A and an output B, and these could be in sync or they can be complementary, so you can set them up in a variety of ways. And then there are some additional terminals here, and this is used to interface with the activation devices. The activation devices can be external to the system, such as a simple push button, or they may come from another part of the system, such as a control card for a more advanced push button, or from a loop detector. And they would serve to power those systems from the internal power supply. But in addition, the signals coming back from those units would come back into the activation terminal here. Basically, all activation devices serve one function, and that is they act as a relay. The relay is open normally, and when the system senses a pedestrian in one way or another, that relay closes, and by closing it will activate the system. Let's demonstrate the proper connect mode for the energy sources. We're first going to use the circuit breaker for the battery connect, and then the second circuit breaker for the solar panel. So first the battery, then the solar panel, and we note that the external lights are flashing. We also note that the counter on the control card is counting down. The green active light, it remains on, and the yellow output light is flashing in sync with the pattern that's being generated on the external lights. We also note that there's a green light on the charge controller and a green light on the control card, indicating that the solar panel is charging the battery and supplying energy to the control card. Next, we're going to take a close-up of the control card when the power is turned on. So I'm turning on the battery and the solar panel, and you can see that the counter, the display, is counting down. The green active LED remains on, and the yellow output LED is flashing. The green power indicator on the control card is on. Next, we have a close-up of the charge control unit. As you notice, there's an input from the solar panel, an input from the battery, and an output to the system, which, if you recall, we call the load. In addition, we have the charging indicator, which is green. When the charging indicator is not green, that means the power or energy is not being supplied by the solar panel and the battery is not in a charge mode. The low voltage disconnect that we talked about is a red LED, It's indicated here, and you note that it is in an off state, which means that the output is connected to the system. If that red LED was on, that would indicate that the system has been disconnected from the energy source or from the battery. I'm now going to demonstrate the functioning of the low voltage disconnect on the charge controller. If you recall, the function of the low voltage disconnect is to protect the battery from being discharged too deeply. The LED indicator is off. This is the red LED indicator that signifies that the output has been disconnected from the system. Now, for the purpose of this demo, I'm using a power supply to simulate the battery itself. So I'm going to turn down the voltage of the power supply until that red LED comes on. You'll see this red LED right here turn on as the voltage reaches around 11.6 volts. And there you go. Now when that red LED turned on, this system was disconnected, so now the system would not be functional. So if you came across a system, it wasn't functional, and you looked in here into the enclosure and you found that red LED on, then you know the output was disconnected, and then you're going to have to look backward to see if the problem is with the battery or the problem was with the solar panel. The initial problem might be the battery, the voltage is too low, but then the question comes up as to why that battery is too low, the voltage level is too low, and that's most likely because it wasn't charged properly by the solar panel. Next, I want to give you a close-up of the circuit breakers, which are on the right, and the surge protection device, which is on the left. That's the dark unit. Now, the surge protector, there is a window, and the window is right there. And if that is not lit, then the surge protector device is not damaged and is functional. If that window was red, that would indicate that the surge protection module has a fault in it, and the particular type of surge suppression devices we use are modular, meaning the unit can be removed and a new unit plugged back in. So I'm going to demonstrate that. So if I go over to the surge protector unit, I can pull out the module and then come back in, replace it with a new module, and the system is once again functional.